So today we will start with question number 76. Okay. So question number 76 is asked in engineering service ESE 2019. Okay. So what it says, the plastic limit and liquid limit of soil are 30% and 42%. So plastic limit WP is 30% and liquid limit WL is 42%. The percentage volume change from liquid limit to dry state, from liquid limit to dry state is 35%. So liquid limit to dry state, volume at liquid limit minus volume at dry state divided by volume at dry state is 0.35 of the dry volume. Similarly, the percentage volume change from plastic limit to dry state, from plastic limit W, from plastic limit to dry state is volume at plastic limit to dry state Vd divided by Vd is 0.22. So we have to calculate the shrinkage ratio will be nearly. So what is shrinkage ratio? Shrinkage ratio is volume V1 minus V2 divided by Vd and corresponding change in liquid limit W1 minus W2. So uh, we can see this expression using this graph. If we take a graph uh, of volume versus water content, then it will be like this. It will be like this. This is WS. This is shrinkage limit, water content and shrinkage limit, and this is volume is corresponding volume is volume dry VD, dry volume. Okay, and if this is W2 and the corresponding volume to W2 water content is suppose V2 and corresponding to W1 water content, the volume is V1, then this will be the shrinkage ratio. And in this case, the volume is given at the volume is given the volume is given at the volume is given at W1 water content. W1 is, if we take W1 as liquid limit, WL, then this volume is VL. And if we take W2 as plastic limit WP, then this volume is VP. This is V dry. So we have to calculate this ratio. So W1 minus W2, W1 minus W2 is nothing but WL minus WP, and this is 0.42 minus 0.30 is 0.12. Now we have to calculate the ratio V1 minus V2 by Vd. To calculate this expression, if we subtract these two equation 1 and 2, we will find this ratio. This is V dry Vd. So by taking the difference of equation 1 and equation 2, equation 1 minus equation 2, we will get VL minus Vd divided by Vd minus Vp minus Vd divided by Vd is equal to, if we take common Vd, this is VL minus Vd minus Vp plus Vd. Okay, and this is equal to, and this is equal to, and this is equal to this is equal to taking this here. This is equal to VL. Let me clear first this one. If we take the difference of these two, then we will get this is 0.35 minus 0.22. So this difference is, take common VD. This is VL minus VD minus VP plus VD is equal to 0.13. VD and VD cancel out, and this what we have is VL minus VP divided by VD is equal to 0.13. So the shrinkage limit will be these two ratio, 0.13 divided by 0.12. So this is this ratio. Now we have this ratio is nothing but 0.13. So shrinkage ratio is nothing but these two ratio, 0.13 divided by 0.12. Shrinkage ratio, this limit, this ratio, and 0.13 divided by 0.12 is 1.08, and you can approximate it as 1.1. So the answer will be 1.1, option number D. Now this question is asked in engineering service ESE 2019. Okay, so now we will take question number 77. Question number 77. Okay, question number 77. Question number 77. So this question number 77. Let us read. The ratio of a given volume change in a soil expressed as percentage of dry volume to the corresponding change in water content is called. This question is also asked in engineering service ESE 2019. Same question, question number 76 and question number 77, same question and asked in same year. Okay, asked in same year. Asked and asked in same year. Okay, 2019. So let me read this again. The ratio of given volume change in a soil expressed as percentage of the dry volume. So it is saying that V1 minus V2 by V dry, V1 minus V2 by V dry to the corresponding change in water content divided by corresponding change in water content W1 minus W2. And what is this? This is nothing but shrinkage ratio. So the option C will be the correct answer. Okay. Let me write the definition of shrinkage ratio. Shrinkage, shrinkage ratio of soil, shrinkage ratio of soil. The ratio of a given volume, the ratio of a given volume, the ratio of a given volume change, given volume change in a soil, in a soil expressed as percentage of the dry volume, percentage of the dry, percentage of a dry volume to the corresponding to the corresponding change in water content. Okay, that is what, that is shrinkage ratio is equal to V1 minus V2 by Vd divided by W1 minus W2. And this is nothing but gamma dry divided by gamma W. And this is already explained in question number 66. This is already explained in question number 66. So why this expression comes, how this expression comes, you can go and revisit the question number 66. Okay, so this question is over. Now take the next question. That is question number 78. Question number 78. Question number 78. A soil sample has porosity of 40%. So porosity is 40%. And the specific gravity of soil is 2.70. If the soil is 50% saturated, if S is equal to 0.5, the unit weight will be nearly. So gamma is what? So this is taken as gamma bulk. So it has gamma bulk. So gamma B is what? So what is gamma B? Gamma B is G plus AC. The formula for gamma B is G plus AC divided by 1 plus E into gamma W. So what is G? 2.70 into S into E. Sorry, 2.70 and 2.70. So we have to calculate first E. What is E? E is, if you calculate E first, then E is porosity eta divided by 1 minus porosity eta. So this is 0.4. Porosity is 0.4 divided by 1 minus 0.4 is 0.4 divided by 0.6. 0.4 divided by 0.6. So this is 2 by 3. Okay. So now we calculate gamma B. Gamma B is G. G is 2.7 plus SE is equal to 0.5. So that is 1 by 2, 0.5 into E is 2 by 3. E is 2 by 3 divided by 1 plus E is 2 by 3 into gamma W. Into gamma W 9.81. Okay. 0.81 kilonewton per meter cube. Kilonewton per meter cube. So this 2 and 2 get cancelled out. So we have what we have. When you calculate this, you will get 17.85. 17.85. This is nearly 18 kilonewton per meter cube, and the option C will be the answer. Okay. Question number 78. Now we have done question number 78. Okay. Now we will see question number 79. Question number 79. Question number 79. Oven dry mass of a pat of clay is 10.8 gram. So dry mass is nothing but mass of solid. So we can ignore the uh, mass of air inside the soil, dry soil. So weight of dry soil or weight of solid is same. Again, this is error. Okay. So W solid, mass of solid is WS. WS is equal to mass of solid is 10.8 gram. and the mass of mercury displaced on immersion is 84.2, and the volume of uh, dry soil VD, volume of dry soil VD is uh, volume of dry soil VD is 80. I think the mercury displaced on immersion is 84.2 gram. So volume of dry soil, volume of dry soil, dry soil mass is equal to volume displaced, volume displaced, and the volume displaced is volume of soil mass, volume of dry soil mass is equal to volume of volume of mercury displaced, mercury displaced, volume of mercury displaced. And here the weight of mercury displaced is given. So weight of given, weight of mercury, weight of mercury, I will write it as Hg, weight of mercury displaced, weight of mercury displaced is equal to 84.2 gram, and density of mercury is 13.6 gram per centimeter cube. So the volume, from here we can calculate the of volume of Hg, volume Hg displaced is equal to 84 84.2 gram divided by 13.6 gram per centimeter cube. And if you calculate this ratio, you will find 6.6.19 centimeter cube, or this is 6.19 cc, centimeter cube. Okay, so volume of Hg displaces this one. So from here, uh, volume of dry soil mass is equal to volume of mercury displaced, and this will be what? 6.19 cc, 6.19 cc. The shrinkage limit of the soil will be nearly. So shrinkage limit, we have to calculate WS, shrinkage limit. Okay, so at shrinkage limit, we have to calculate shrinkage limit. Let me draw the graph here. What we have to calculate is water content. We have to calculate this. Here S is equal to 1. Here S is equal to 1. This is V dry. Okay. So to calculate is WS is nothing but weight of water at shrinkage limit, weight of water, weight of water present in soil at shrinkage limit divided by weight of solid divided by weight of weight of solid, weight of solid. Okay, so what is the water content at this stage? We have to calculate this first. To know this, uh, we can use the formula SE is equal to G into W. SE is equal to G into W. So from here, this is S is equal to 1, and this is shrinkage limit as shrinkage limit. This is WS. G is given. G is also given. That is 2.72. The only we have to calculate the void ratio E. So void ratio E is equal to volume of void upon volume of solid. And volume of solid, we know, do we know volume of solid? Do we know the volume of solid? Hmm. The dry mass of a pat of clay is this one. Dry mass, we have dry mass, and we have a specific gravity. Then we can calculate volume of void also. So the volume of void is uh, so first we have to calculate volume of void. We have volume of solid. So volume of void, uh, where we have volume of solid, volume of solid, we don't have volume of solid. What we have, is actually we have volume of soil sample at dry state, and it is total volume is 6.19, and we have to first calculate volume of solids. If we calculate the volume of solids, then we can easily calculate the volume of voids by subtracting volume of solid from total volume. Okay, so how to calculate volume of solids? So we have weight. The weight of solid is 10.8 gram, and the specific gravity is 2.71. So weight of solid is 10.8 gram, 10.8 gram, and the specific gravity of solid GS is equal to 2.72. So from these two data, we can calculate the volume of solid, and the volume of solid is 10.8 gram divided by specific gravity, divided by specific gravity, not cannot take it as gram. 10.8 divided by a specific gravity is 2.72. So this will be in a cc, and this is 3.970. 3.970 cc is the volume of solid. So volume of solid is this. So volume of void is total volume minus volume of solid, and total volume is 6.19 minus 3.970 is equal to uh, if we subtract these two, we will get, let me subtract it. So we will get this, subtract is 6.19 minus 3.970, that is 2.22. This is 2.22. So from here, the void ratio E is equal to volume of void, that is 2.22, and the volume of solid is 3.970, 3.970, and this ratio, when we divide by 3.970, is 0.5591, 0.5591. Okay, and when we put this E value here in this expression, So S is 1 into E is 0.5591 is equal to 2.72 into WS. So from here, WS is equal to 0.5591 divided by 2.72. And if we divide this with number 2.72, 2.72, we will have 0.205. So this is 20.5%. 20.5%. So this is very close to option number D, 21%. So 79, the option D will be the correct answer. Okay. So the next question is question number 80. 80. Let us solve question number 80. Question 80 is the porosity of a soil N is. So what is porosity? N is equal to E divided by 1 plus C. E is wide ratio. So E divided by 1 plus C, option number A. So 80, option number A is the correct answer. Okay. Now question number 81. Now question number 81. What is 81? A soil has bulk density of 20.1. So gamma B is equal to 20.1 kilonewton per meter cube, and water content is 15%. What is the water content if the soil partially dries to 19.4 kilonewton per meter cube and the wide ratio remains unchanged? So we have to calculate gamma is equal to what if what what is the water content. Okay, if we have to calculate water content, we have to partially dries, so we have to calculate water content. W is equal to what for gamma to be 19.4 kilonewton per meter cube. So gamma B, what is gamma B? Gamma bulk is equal to G plus SE divided by 1 plus E into gamma W, and E wide ratio is unchanged. Okay, wide ratio is unchanged. Here only S is changing. G will remain same, gamma W will remain same. Okay, and this case, this is gamma, let me take it as gamma prime. Okay, so from a relation G W is equal to SE, if we eliminate E, so this is G plus G into W divided by 1 plus E into gamma W. Okay, so this is gamma B, and if we take gamma prime, then G will remain same plus G will remain same into W will become W prime, where 1 plus E will remain same into gamma W. When we take these as ratio, that is gamma B divided by gamma prime, then this will be uh, if we take G out, so that is if we take G out, so G 1 plus W into gamma W divided by 1 plus E multiplied by 1 plus E divided by, we take G out from this, so this 1 plus into gamma W. So gamma W cancel out, 1 plus E cancel out, G and G cancel out. This is 1 plus W divided by 1 plus W prime. Okay. So from here, gamma B is 20.1, 20, 20.1 divided by gamma prime is 19.4. This is equal to 1 plus W divided by 1 plus W prime. And W is nothing but 15%. So you can take this as 0.15. So from here, 1 plus W prime is equal to 1 plus W prime is equal to 19.4 divided by 20.1 divided by 20.1 divided by 1.15. So from here, 1 plus W prime, and this, if we calculate this, 19.4 divided by 20.1 is 0.96 and multiplied by 1.15, then this is 1.109, or we can yeah, and we can take it as 1.11, 1.11. Okay, so uh, from here, W prime is equal to 1.11 minus 1 is equal to 0.11. So this is around 11%. This is around 11%. Okay. So A is very close to this. Option number 81 will be the answer. Okay. Now question number 82. Question number 82. Question number 82. A fine-grained soil is thought to have a liquid limit of 90%. So WL is equal to 90% and plasticity index is 50. So plasticity index IP is 50. The natural water content Wn is equal to 28. What is the liquidity index? What is the liquidity index? So first we know that consistency index plus liquidity index is equal to 1. And what is consistency index? IC is equal to WL minus WN divided by WL minus WP. So WL minus WN, and WL minus WP is nothing but plasticity index IP, and WL is 90%, so 0.9 minus WN is 28% is 0.28 divided by IP, and IP is uh, 0.5. Okay, so when take ratio of these two, 0.9 minus 0.28 divided by zero point 0.5, this is 1.24. This is 1.24. So IL is equal to 1 minus 1.24. This is minus 0.24. So option number C will be the answer. 82. Option number C will be the answer. Okay. Now this question is over. Question number 83. What is question number 83? A sample of silty clay has volume of 14.88 centimeter cube and a total mass of 28.81 gram. The dry mass is 24.83 gram and the specific gravity of solid is 2. What is the void ratio? So total volume of sample, volume of soil sample, soil sample is 14.88 centimeter cube, and volume of weight of, not volume, weight of weight of soil sample or mass of soil sample is equal to 28.81 gram, and the dry mass, not dry volume, this is dry mass. So dry mass, dry mass, a dry mass is dry mass of soil sample. Dry mass of soil sample is 24.83 gram. Okay, and a specific gravity GS is equal to 2.7. 2.7, calculate wire ratio. So wire ratio is volume of wires upon volume of solid. So volume of solid, we can calculate volume of solid from this and this one. Okay, dry mass is dry mass of soil sample, and uh, weight of mass of solid will be same. So weight of or mass of soil solid is equal to dry mass of soil sample, because we neglect the mass of air in comparison with mass of uh, solids. So we can take these two equal, and dry mass of soil sample is equal to, this is 24.83. So from here, uh, using the specific gravity, we can calculate the volume of solid. So from here, volume of solid volume of solid is equal to 24.83 divided by 2.7. So 24.83 divided by 2.7 is 9.196. 9.196. 9.196 centimeter cube, or cc, or cc. Okay, or cc. Okay, so this is volume of solid, and total volume of soil sample is this one, 14.88. So volume of wired volume of wired PV is equal to volume of soil sample, volume of soil sample minus volume of solids. Volume of solids is equal to, volume of soil sample is uh, volume of soil sample is 14.88 centimeter cube, minus volume of solid is 9.196. So 14 point minus 14.88 is 5.683. 5.683 is, I think, what, 4. This is centimeter cube. Okay, volume of wires is this one. So, and volume of solid is this one. So, the wire ratio E is equal to volume of wires is 5.684, 5.684 divided by volume of solid is 9.196, and this is equal to, if we divide with 9.196, 196, 9 point. We divide this number with 9.196. We will have 0.618. 618. Okay. So the option number C, exact matching with this 0.61618. This will be the answer. 83, option number C. Okay. Now question number 84. Now question number 84. What is 84? The void ratio of clay sample is 0.5, given E is equal to 0.5, and the degree of saturation S is equal to 70% is 0.7. What is the uh, bulk unit weight of solid bulk unit weight of soil? G is given as 2.7. So you know that gamma B is equal to G plus SE divided by 1 plus E into gamma W. G is 2.7 plus S is 0.7 into E is 0.5 divided by 1 plus 0.5 into gamma W is 9.81 kilonewton per meter cube. So if you calculate this expression, 2.7 plus 0.35 divided by 1.5 into 9.81, this will be 19.947 kilonewton per meter cube. This is nothing but 19.95 kilonewton per meter cube. So D will be the option 84D. Okay. So 84, now 85. Now 85. Now question 85. Consistency in a term is a term used to indicate. Consistency is a term used to indicate the quantitative analysis of soil, the degree of firmness of cohesive soil, the fineness of non-cohesive soil, the fineness of clay soil. So this is uh, consistency is not related with fineness. So option C and option D cannot be the answer, and the answer will be 85. The answer will be B actually. So it is indicated, consistency indicates degree of firmness of cohesive soil. Okay, so if we explain this, so we can write corresponding to this question is consistency is a term. Consistency is a term which is used to describe which is used to describe the degree of firmness degree of firmness of a of a soil in a qualitative manner, in a qualitative 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 manner by by using using descriptions by using descriptions such as soft, medium, soft, medium, firm, stiff, stiff, or hard, or hard. It refers to the it refers to the resistance resistance offered by resistance it offered by it against against force that tend to deform force that tend to deform or rupture deform or rupture the soil aggregate soil aggregate. Consistency is directly related to consistency is directly related to consistency is directly related to strength and and depends on depends on moisture content of soil. moisture Moisture content of soil. Okay, this is all about this question, so answer will be B. Now question number 86. Which one of the following is a method of wet mechanical analysis of a fine grained material? That is, uh, you know, very famous wet mechanical analysis is hydrometer method. Okay, hydrometer method and pipette method. So in this, these two option is not here. Okay, we have to choose the answer from the option partial sedimentation, sed sedimentation into dirty water, observation of partial sedimented soil, and illustration. So answer will be illustration. What is illustration? So illustration is just think of this as a reverse sedimentation. Illustration is nothing but the reverse sedimentation. Let me explain this here. What is illustration is think of this think of this think of this as reverse sedimentation. Reverse sedimentation. How this process works? So the process what is the process? The process, instead of letting particle instead of instead of letting particle instead of letting particle fall through still water. Instead of letting particle fall through still water, we use rising current. We use rising we use rising current of water or air. But in this case, we will use water, rising water. What is the logic? What is the logic behind it? So the logic, so what is the logic? So logic is if the upward velocity, if the upward, if the upward velocity of water, if the upward velocity of water is greater than the settling settling velocity of a particle of a particle, that particle will that particle will be carried upward, will be carried upward and out of the container, and out of the container. The grading, grade, the grading by carefully controlling the speed, by carefully controlling controlling the speed of the rising water, rising speed of the rising water, we can wash away, we can wash, we can wash away, we can wash away smaller particles, smaller particles, while keeping, while while keeping larger ones, by keeping larger ones at the bottom. Oh my God, this is something error. By keeping larger ones, by keeping larger ones at the bottom, at the at the bottom, effectively sorting the soil by size, effectively effectively sorting the soil by size. Okay, This is all about illustration. Okay, so there are many method of wet mechanical analysis of fine grained soil. Okay, so one of the method is illustration, and the next method is decantation. So what is decantation? So let me decantation also. Let me clear it first. This is illustration, and the next wet mechanical analysis of fine grained soil is decantation. What is decantation? Let us understand it. Decantation. What is this? So decantation is the simplest form of decantation. Let me change the color. Decantation is the simplest form of decantation is the simplest form of sedimentation analysis. Sedimentation analysis. Okay. It is manual process of separation by gravity. It is manual process of separating. What is this here? This is the manual process. This is the manual process. Manual process of separation by gravity. And how it works? How it works? How it works? A soil water suspension. A soil water suspension is stirred is stirred and and then allowed to stand for a specific amount of time. Stand for a specific amount of time. Based on Stokes law, based on Stokes law, the larger particle the larger particle settles to the bottom quickly, to the bottom quickly. Okay, so first discuss about what is Stokes law. So what is Stokes law? Stokes law gives the velocity of settling velocity of particle, and it is g minus 1 gamma w d square divided by 18 mu. Mu is dynamic viscosity of water. Gamma W is unit weight of water. D is diameter of particle. G is a specific gravity of particle which is settling. Okay. And this equation is valid for a specific condition. And the condition will be like this. Writing here. First condition is the particles are perfectly spherical. The particles are perfectly spherical, which is impossible. Okay. The the soil soil particles are often flaky or angular, are often flaky, often flaky or angular. Okay. The second condition is the liquid is infinite in extent. The liquid is infinite. Liquid infinite in extent. Liquid is infinite in extent. The wall of container does not interfere. That is, the wall of container, the wall of container does not interfere. The wall of container does not interfere. Okay. And the third condition, the particle are of certain size. The particle are of certain size. And what is this? The particle size should be in between 0.2 mm to 0.0002 mm. Okay. If the particle is in this range, then Stokes law will work. Otherwise, Stokes law will not work. Okay. So why it is so? So if particle larger than 0.2 mm, if particle larger than larger than 0.2 mm causes turbulence, causes turbulence, causes turbulence, and particle is smaller than, and particle is smaller than 0.2 mm, Brownian motion making the law inaccurate. Brownian motion making the law inaccurate. Okay. So decantation is also a method of wet mechanical analysis of fine-grained material. And there are many more methods. Okay. There are many more methods. So I can write the name of these methods, but explanation will take a lot of time. So only I am going to uh, name the methods of wet mechanical analysis of fine-grained soil, And these are first one is decantation, decantation, decantation. Second is illustration. Second is illustration. Actually, in decantation, only I come to the Stokes law and uh, in it. So let me explain first decantation. Okay, I'm sorry for that. So decantation only I tell about the Stokes law. Okay, after that, how it the action I didn't explain the action. So let me explain the action in decantation. So what is the action? The action, the action. So once the required time has passed, once once the required time has passed, once the required time has passed, the liquid at the top, the liquid at the top, the liquid at the top, which is still contains the final particle, which still contains the final particle, is carefully poured off, is carefully poured off, is carefully poured off, carefully poured off. Okay, this is nothing but it is called decanted. The top water is decanted. I'm writing this in bracket, decanted into another container, into another, into another container. Okay, what is the purpose? Let me explain the purpose. This purpose, it is the purpose. So this is often repeated multiple time. This is often repeated, repeated multiple time, multiple time, multiple times to wash, to wash the coarse particle, the coarse particle, the coarse, the coarse particles, and separate them, and separate them, and separate them, and separate them, and separate them from the clay and silt, from clay and silt, clay and silt. Okay, this is all about decantation. So wet mechanical wet mechanical analysis of fine grained soil is first one is decantation. The second we study about filtration, and the third is hydrometer method and pipette method. You already know these two. The new one is filtration and decantation. So there are several methods. Let me write the name of all methods so that in future, if question comes from this, you can easily uh, solve this. Okay. So the first one is decantation. Decan Decantation. The second is filtration. Third is pipette method. Pipette method. Pipette. Pipette. Pipette method. Fourth is hydrometer method. Hydrometer method. Fifth is fractional sedimentation. Fractional sedimentation. SED. Fractional sedimentation. Okay. Sixth is accumulative sedimentation. Accumulative. Accumulative sedimentation. Accumulative sedimentation. Accumulative sedimentation. Sixth. Seventh is manometer method is also a method. Manometer method. Manometer method. Okay, manometer. MANO. Mano. METER. Manometer method. Okay. Eighth is centrifugal method. CENTRI. CENTRIFUGAL. FUGAL. Centrifugal method. Eighth. Okay. These are the methods. Okay. So today, this is all for today. Okay. The pen is not working well because this file is going to be big, and that's why the pen is not working properly. So it is this is all about today. Thank you everyone.